Welcome to point channel. So today I will discuss about at the rate one to many bidirectional association. So in this demo I'm going to cover what exactly at the rate one to many bidirectional association and when do we need to use this. Okay, and how to insert parent and child entity records. Okay, and what happens if we wrongly link child to parent association. Okay, and similarly, can we fetch from, parent and child entity records from both the sides? Okay, is it possible? Okay, and how to delete a specific parent entity record and how to delete all or a specific child entity record for a specific customer ID. Okay, so I'm going to discuss all these points. Yeah, so without wasting time, let's jump into the coding part. Yeah, so just some time before I have created a demo project. Okay, here if you see one to many bidirectional mapping. So uh, let me walk through the code. Okay, so here we have two entities. This is a customer entity, which is nothing but a parent entity. Okay, hardly it has the three fields: customer ID, name, and mobile number. Okay, so and here loan is a child entity. Okay, so hardly it has four fields: loan ID, amount, issued date, and loan type. Okay, so since it is a bidirectional association, okay, obviously we need to establish a association from both the sides, right? So now first see the parent entity side. See at the customer side. So we need to annotate like this. I mean, so obviously see one to many association in the sense one customer can have multiple loans and many loans can be associated to one particular customer. So this is kind of a one to many and many to one association. So here if you see as part of that I have list of loans. Okay, so here if you see at the rate one to many is annotated here and I'm just passing few attributes. Cascade is equal to cascade type dot all and fetch is equal to fetch type dot lazy and orphan removal equal to true. Okay, so I mean I have already explained about all these attributes in my previous video. So if you have not watched my previous video, please watch my previous video. Okay, so now if you see child entity side, even loan side also here, if you see, I mean, we have established the association something like this at the rate many to one fetch is equal to fetch type dot lazy and private customer. Obviously many loans can be associated to single customer, right? So like I mean that's why we have coded like this. Okay, so after that, yeah, we have two repositories, one for customer and second is for loan repository. Okay, so I have some utility package in which I have some lazy testing class. Okay, so just to overcome the problem of lazy initialization exception, I have written this class. I will explain after some time. Okay, so here if you see, this is just a main class in which we have a main method. That's it, nothing fancy. Okay, so here if you see, yeah, resources application dot properties. I'm just maintaining MySQL database related data source properties over here. Okay, now I'm just having test scenarios just to what do you say, explain explain about the what do you say, benefits of bidirectional association. So I have written few test scenarios. So this is the high level code walkthrough of my particular demo. Okay, so let me explain all the possible cases over here. Okay, so in my previous video, I just talked about what you say, at the rate one to many unidirectional association and as well as at the rate many to one unidirectional association. So now in this video, we are going to discuss about bidirectional association. So that means at the rate one to many at the parent entity side and at the rate many to one at the child entity side. So when we keep both, what happens? How what are the benefits out of this? Okay. So now if you see, so case number one. Here if you see loan side at the rate many to one fetch is fetch type dot lazy. So if you remember in my previous video, as soon as we add this type of annotation at the rate many to one, what does it happen? I mean, internally Hibernate will create one foreign key column within the loan table with the name customer underscore ID because of this particular annotation. That's what we know, right? So, so obviously it will do the same now also. So now here, if you see in the customer table, okay, we have annotated with at the rate one to many and general attributes. Cascade is equal cascade type dot all, right? So now, I mean, um, as per my previous video, okay, if you go through my previous video of at the rate one to many unidirectional association, so what happens? Hibernate will create one more brand new table, something like a customer underscore loans, in which we have two columns, customer underscore ID and loan underscore ID. So now what happens? Obviously, since I have at the rate one to many, so because of this code snippet, it will create a brand new table, as I said. And here, if you see, since we have at the rate many to one, so in the loan table, it will create a one more column, foreign key column. So these two effects are going to be reflected, right? So now let's see the first test scenario here. Okay, so here if you see insert customer records, okay, I just added this piece of code in lazy testing utility class. So here if you see, I just added two sets of records. So in the first set, customer one something something Rajendra, his mobile number, and I just created three loan records. So that is personal loan, home loan, and gold loan. Okay, so here if you see, I'm passing this customer one to to all these three loans, right? So by that way, all these three loans are associated to this particular customer one. That's what I want to say, right? So now in the bidirectional association, okay, we need to set all these three loans, okay, to the customer also. So that means here we have already done that particular one. Now at the parent entity side, if you see customer one dot get loans, so what does it return? Obviously, it return list of loans, right? Dot add all of, okay, add is dot as a list of these three loans. So that means I'm just adding these three loans to the list of loans of this particular customer, right? So that means I have tied all these three loans to this particular customer, right? Now, um, here child to parent entity side. Now in this particular line, what we are doing, parent to child entity side. At the parent entity side also, we are tying all these three loans to this particular list of loans of customer. Now I'm simply saving the customer, right? So since this is a bidirectional association, we need to set the parent entity within the loan, and as well as we need to set all the list of loans within the parent entity also. And finally, we are saving the parent entity here, right? So since we are maintaining cascade is equal cascade type dot all at parent entity, so obviously it will save the parent entity record and its associated all the loan records. So now this is one more set, same thing, one more set here. Customer 2 has only two loans, that is bike loan and car loan, that's it, right? So here also, if you see customer 2, I just added like this. Now let's run this particular test case. Okay, so here if you see, uh, yeah, first test case, insert customer record. Yeah, I'm just running here. If you see in the database, as of now, nothing. Okay, no tables. Okay, so let's wait for some time. Uh, it will take a while. We will see the results. So as I said, yeah, it will create a brand new table with customer underscore loans with the name. Okay, and it will create a one more foreign key column in the loan table because of at the rate many to one association. Okay, so here if you see, so this one, so because of this piece, it will create a new table, and because of this piece, at the rate many to one, because of this, it will create a foreign key column in the loan table. So yeah, test case is passed. Okay, I'm just refreshing. Here you see we have three tables: customer underscore loans, and loan, right? So here if you see, I'm just refreshing. Yeah, so Here, if you see first three loan records are linked to the customer one, and the second set of two loan records, that is loan number 4 and 5, are linked to customer two. Okay. Now here, if you see, we have two customer records. Okay. Here in the customer and school loans, obviously we have five records. Yeah. So this is the case one, whatever we discussed so far. So now the second case, case two. I don't want to create this kind of new table with the name customer underscore loans. Okay, I want to keep only customer table and as well as loan table, and within the loan table, I want to keep the foreign key column as customer underscore ID. Right. So for that, what we need to do? Okay. So for that, okay, go to customer table here. Okay. So here we need to add one more important attribute. Okay, that is nothing but mapped by. Okay, so mapped by customer. So now what is this mapped by? What is this customer? So this customer is nothing but this variable name. Yeah, this variable name. So within the loan entity, obviously we have private customer, right? So this customer we need to specify over here. So that means Hibernate internally what I mean internally decide that, okay, now since we have a mapped by equal to customer, so from now onwards, I mean, I'm going to map all these loan records to this particular customer, what do you say, customer ID of this particular loan entity. So no need to create a new table. So by that way, both records are internally linked with each other, right? So now let me drop the tables once again. One second. Let me drop the tables. Yeah. So now all tables are dropped. Okay. I'm just refreshing. Okay. Yeah. Nothing. So now let me rerun the same test case once again. Okay. So here, if you see, oh, sorry. So here I'm just running this particular test case. Yeah. So yeah, just we'll wait for some time. I mean, let it run. So as I said, let me recap. Okay, so I'm just closing all the things. Okay, so within the customer, I mean, just now we have added mapped by attributes. So because of mapped by attribute, internally it will take the decision that not to create a brand new table. Okay, so it is going to link this parent entity records with the child entity records with the help of that foreign key column in the loan table. That is nothing but this one. This is nothing but a foreign key column. This acts as a foreign key column. Okay. So yeah, test case is passed. Let's examine the results. Okay. So I'm just refreshing. Yeah, here you can see we have only two tables, customer table and loan table. Okay. Now I'm just fetching the loan records. Yeah, happily five records are created. First three records are linked to customer one, and second two records are linked to customer two. Right. So here you can see, uh, yeah. So two customer records. So this is case two. Okay. So now case three. Okay. So what we do? Okay. So come here. Sorry. Yeah. Here, go to this particular code snippet. Yeah, here what we do, okay, now this particular code scenario. Okay, here if you see, okay, I have three loan records, right? Personal loan, home loan, and gold loan. Obviously they are linked to customer one. Now when I'm adding all these three loans to the what do you say, list of loans of a customer one, so then I have not added the gold loan. So just keep this point, I have not added the gold loan. Here you can see arrays.as list of only personal loan, home loan. Gold loan is not added. However, internally gold loan is already linked to customer one, right? Now what happens? See, we have one more set. Okay, one more set. I mean, where customer two is linked to two loans, that is bike loan and car loan. Now I'm going to tag this particular gold loan to the second customer. Here you can see as a third loan. Okay, I'm just tying this gold loan to customer 2. So this is kind of a wrong association, right? Why? Because see here if you see line number 53. Okay, loan gold loan, here you can see already it is linked to customer 1, right? It is supposed to add to the customer one's list of loans, right? Here we are supposed to add. Why? Because I mean it is linked to customer one. So by mistake or intentionally, if you add this gold loan to the customer two, okay. So now what happens? So there are two possibilities. Okay. So if it takes the priority, okay, if this line takes the priority, so then obviously custom what is say gold loan is added to customer one only. Okay, and in this particular line will get ignored. Okay, and similarly vice versa, if it gets more priority, so now gold loan gets added to customer 2, and this line will be ignored or something like that. Okay, so now let's see what happens. Okay, so yeah, so this is that um, yeah. Yeah, I'm just running this particular test case. So in this case what happens, okay, let me tell you. Okay, so here customer is a parent entity, okay, and loan is a child entity. So obviously uh, this loan table acts as a owning side. Why? Because in the loan table we do have a foreign key column. So wherever we have foreign key column, obviously what you say, it acts as a owning side, and this customer table acts as a non-owning side. So always owning side uh, what you say will be considered as a bit high priority one. So that gets a more precedence. Okay, so here if you see test case is passed. Okay, so um, yeah, let's examine the results. Okay, I'm just refreshing. Okay, to yeah, yeah, here if you see one, two, three. So first three records are linked to loan customer one, and I mean loan number 4 and 5 are linked to customer two. So now what that means, what does it mean? What's the conclusion here? If you see, so this particular line number 53, line number 53 took the high priority. Why? Because loan is nothing but a, here in this case, loan acts as a owning side. So whichever entity is acting as the owning side, basically that will win. So that considers a very high priority. So this particular line, what is say, was considered by Hibernate. So by that way, gold loan is associated to this particular customer one. So now here I mean so here this line will be ignored in the sense, so gold loan is not tied to this customer too. So that's the internal point. Okay, so so this is one case, and the second case. So by looking at this particular scenario, we make it one doubt. Okay, so can we think in a reverse way? So that means what happens if customer acts as a owning side and the loan acts as a non-owning side? So then, if it happens really, then what happens? Ideally, owning side will win, right? So then customer side will win. So then in that case, this line will be having a more priority than this particular line. Okay, than this particular line. So then what happens if we execute the same code, then this time, even though gold loan is linked to this particular customer one, so then because of this high precedence of this particular line, finally this gold loan is added to customer two. So let's see this particular case also. So how to I mean how to make customer as a owning side, right? So for that, okay, what we need to do, here if you see, I'm just removing this mapped by. Okay, yeah, I'm just removing. Okay, I'm just adding one join column. Okay, name equal to customer underscore ID. Okay, yeah, yeah. So if you remember, I mean, in my previous video, so um, at the parent entity side, whenever we write this kind of at the rate join column just below at the rate one to many, then what happens? I mean, it will not create a brand new table. In fact, it will try to create a foreign key column within the loan table because of this highlighted line. Okay, so that's what we have already seen, right, in our previous video. So now because of this line, it will not create a new table with the name customer underscore loans. In fact, it will create a foreign key column within the loan table. Now, okay, we go to loan table here. Here, there would be one conflict. So I also said that whenever we add at the rate many to one, okay, it will also try to create a foreign key column within the loan table, right? So then ideally, what do you say? There could be two possibilities, right? So then we need to switch it off with the help of, okay, settable false, dateable false. Yeah. So we just need to add these two attributes so that uh, it will create a foreign key column just because of this particular line. So that means by that way customer acts as a owning side. Now loan acts as a non-owning side, right? So now let me drop this particular tables once again. Okay, just before running. Yeah. So let me refresh. Let me refresh. Yeah. So yeah, here, okay, I'm just running this particular scenario. Loan underscore owning side. Yeah, this one. So now I'm just running. Okay. So now if you see this code, okay, same code here. If you see, say same code. Okay, same code in the sense, I mean, gold loan is linked to customer loan, and of course, we are not adding to this customer one's loans list here. Okay, here if you see, we are not adding. In fact, we are adding to customer two's loans list. Okay, here we are adding as a third loan. Okay, so now since we just made customer as a owning side, now this particular highlighted line will win, and gold loan is added to this time customer two. Gold loan is linked to customer two. Okay, that's what we are going to see just shortly. So it will take a while. Yeah, test case is passed. Okay, so let's examine the results. Okay, uh, so go to loans. Okay, yeah, so yeah, here do observe that gold loan. Yeah, this is important. Gold loan is associated to this customer two. Okay, that's what I said, right? Now, if you see, personal loan, home loan are linked to customer one. Now, customer two has three loans. So till now, customer one has what you say three loans, and customer two has only two loans. Now, it was simply got reversed. Okay, so I hope you guys understand this particular concept, right? So yeah, so since we made customer as the owning side, so this particular line took a bit high priority, and by that way, gold loan is added to this particular customer too. So right, okay. So now go to test cases. What is the next test case? Yeah. So fetch customer records and fetch loan records. So now since we have bidirectional association, so happily we can fetch customer records, and obviously it will pull its respective loan records whenever we are interested for loan data. Similarly, vice versa for loan records. So let's see now here. Okay, I'm just what do you say? I'm just running this particular scenario here. If you see what I'm doing, I'm just fetching all the customer records. Okay, and I'm just iterating what do you say customer name and its associated loans or something like that. I just use Java 8 streams here, nothing. I mean stream dot what I'm just preparing one map kind of thing in which key is nothing but a customer name and just value as its associated loans list. Okay, so yeah, so here if you see when I'm printing, I'm just printing customer name, and here if you see I'm just printing what do you say all his loans, so with the help of this loan type. Okay, So yeah, so yeah, so we flow is reached to the first line of this particular method. Now console is empty. I'm just moving to the next line. Here you can see. So I mean, it has fetched all the loan customers list. Yeah, so it has fired this particular query. It makes sense. Okay. So now, if you see, come to this particular line. Okay. Yeah. So now, if you see, yeah, it has fired one query. Okay. It has fired one query to fetch all its list of loans of a customer one. So customer one. So that's why this particular query. Okay. Now it has printed here. You can see customer name is Nikita. Okay, and Nikita has what do you say? Three loans: bike loan, car loan, gold loan. Okay. And if you see for customer two, again in the second iteration, customer two, I mean for customer two, it will print customer two name and customer two's loans, right? So that's why it has fired one more query. Here you see one more query, and obviously you see customer two name is Rajendra and he has only two loans. There is personal loan and home loan. So here, what I'm trying to say here is, I mean, um, so here, I mean, we have encountered an n plus one problem. N plus one problem in the sense n is nothing but a number of parent records. Here, parent records are nothing but customer records. So we have two customer records. So that means n equal to two. So how many queries it has fired internally? N plus one. So that means two plus one. That is equal to three. So that means uh, one query is to fetch all customers list, right? Just now you have seen, and the remaining two queries are to fetch each customer's loans list. So first customer's loans list, query number two, and second customer's loans list, query number three. So this is nothing but a Hibernate n plus one problem. Of course, we will see one more video and how to resolve this particular n plus one problem. So for now, I just want to highlight this is n plus one problem. Okay. So similarly, fetch loan records are also here. Let me see once again. So here, what we're doing similarly, uh, reverse. I mean, I'm just fetching all the loans list. Okay, and similarly, I'm just printing what is a loan type and its respective customer name. Reverse. Okay, since we have established a bidirectional association, so I just want to showcase the beauty of fetching records from both the sides. Okay. So here also, I mean, we will encounter n plus one problem once again. Okay, even from child to parent entity side also. Okay, yeah, here you can see flow is stopped. Okay, now I'm just moving to the next line. Yeah, here you can see it will fire a query to fetch all the loans list. Yeah, so it makes sense, right? So now if you see, go to next line, next line. Okay, so here if you see, so obviously, first three loans are linked to one customer, right? So here you can see this query. Okay, it is trying to fetch first customer's details. Okay, here you can see bike loan and car loan are linked to Nikita. Okay, and similarly, one more query. One more query is to fetch second customer, right? Second customer, and here you can see it has printed three loans are linked to Rajendra. So that means first query is to fetch all the loans list. Okay, and the query number two and query number three are to fetch its respective customer details. So here also n plus one problem. Total three queries have been fired. Okay. So I'm just resuming the flow. Okay. Now I think two more scenarios are there. Yeah. So I just want to run this particular scenario. I think here I'm just deleting one customer record. Okay, whose ID is one. Right. So first of all, we will see how many records are there in this tree. Okay, see, customer one has two records here, right? Customer one has two records. That means loan one, loan two are linked to customer one. So now, since I'm deleting this customer one, obviously this what is it here? Yeah, here the first record gets deleted and its associated loan records also gets deleted. Let's see whether it is yeah, still it is in progress. Uh, yeah, test case is passed. Okay, so now first we will examine the customers table. Yeah, so first record whose ID is one got deleted. Okay, and similarly here if you see in the loan table, okay, I'm just refreshing. Yeah, so first two records got deleted. It makes sense, right? Okay, so now if you see here, I just want to uh, run this particular query. Okay, now I want to delete only list of loans of a customer whose ID is 2. So second customer has 3 loans, right? So I want to delete all the 3 loans of a second customer, but I don't want to delete the second customer record from the customer table. So this is the underlying point. Okay, so so here if you see, I just fetched the customer record. What is say with the help of customer repository dot find by ID of 2L. Now what I'm doing here, if you observe, customer dot get loans dot clear. That's it. Now what is say, since we have added orphan removal equal to true here. Okay, here orphan removal equal to true. What happens? I mean, internally it will disassociate the respective list of loans to this second customer. Okay, by that way it will try to delete those records from the database. Now let's see. Okay, so first we will see with the customer. So this record will be intact. Yeah, I'm just refreshing. Yeah, this record is intact. Nothing has happened to this particular record. Okay, now we want to delete these records, right? As soon as I refresh, these 3 records will get deleted. Yeah, boom. Yeah, so yeah, that's it. I mean, so I just covered all the possible scenarios of bidirectional association. Now okay, uh, so I just want to um, so what we learned so far. So if you see case number one, owning side loan. So that means if you see in the parent entity side, okay, when we have it rate one to many with these 3 attributes, cascade and fetch and orphan removal, and at the child entity side, and we have at rate many to one, right? So if we keep like this, then we have observed that total two tables have been created, that is customer and loan, right? So oh sorry, customer and oh sorry. So in the case one, okay, whenever we have this type of association with at the rate one to many, okay, so obviously internally I mean it has created total 3 tables, customer and customer underscore loans and loan table. So within the loan table, so because of this at the rate many to one, okay, here if you see, I guess, can I highlight? Yeah, no, it's not highlighting. Yeah, so otherwise I will, yeah, I guess now I can highlight. Yeah, yeah, so because of at the rate many to one, it will try to create a foreign key column within the loan table. Now because of at the rate one to many, it will create a brand new table, that is customer underscore loans, right? That's what we have observed, right? So yeah, in this case, obviously owning side is a loan table. Now see the second case, case two. So in this case, same scenario, just we have added one more attribute, that is mapped by equal to customer. So in this case, what happens, as soon as we add this new attribute mapped by equal to customer, so internally Hibernate will not create a brand new table. Okay. Um, so what do you say? At the rate many to one, obviously it will create a new foreign key column within the loan table with the name customer underscore ID. Now this customer records are internally linked to this particular what do you say, loan table with the help of the same customer underscore ID. So that's what we are mapped by equal to customer, right? So this is case 2. Now case 3. Case 3, if you see, yeah. Um, so yeah, how to make customer as a owning side. So this is a case 3. So in order to make a customer as a owning side, what we have done, okay, we just removed mapped by attribute and we just added at the rate join column equal to name is equal to customer underscore ID. So in that case, what happens, this parent entity internally Hibernate will not create a brand new table. In fact, it will create a new foreign key column within the loan table with the name customer underscore ID, just because of this particular line. Okay, now so by that way customer is going to act as a owning side. Now we need to stop the creation of a foreign key column with this particular annotation, right? So for that, I mean, I just wrote at the rate join column again name is equal to customer underscore ID. We need to add two more attributes, that is insertable equal to false, updatable equal to false. So that means we are switching off the creation of the foreign key column with at the rate many to one. Okay. So yeah. So this is case 3. Okay. So now case 4. I mean, we have already gone through all these cases just some time before, but yeah, just at high level, I'm just what do you say, explaining all the possible cases. Okay. Here, case 4. In the case of unidirectional association, suppose if you have at the rate one to many only at the parent entity side like this. Okay, and if we don't have any association at the child entity side, then what happens? As expected, I mean, obviously, it will create a new table, customer underscore loans, right? So, um, yeah, so customer underscore loans, yeah, it's my bad. It will not create a, what is a, one second. Um, yeah, yeah, it will not create a foreign key column, right? Why? Because we don't have any association within the child entity, right? So yeah, let me correct this. Yeah, this is the right statement, right? So total we have three tables: customer and customer underscore loans and loan table, right? So yeah, this is case 4. Now see the case number 5. Okay, so here if you see here also same thing. Okay, in the child entity no association to parent, but in the case of what is a parent entity, okay, in addition to this at the rate one to many, I just added at the rate join column. Okay, at the rate join column name equal customer underscore ID. So what happens, internally Hibernate will not create a brand new table. Okay, and in fact it will create a new foreign key column within the loan table. So now yeah, so here if you see total we have only two tables, that is a customer table, and within the loan table now it will we will be having a new foreign key column with the name customer underscore ID. That is just because of this particular line. Okay, now case 6. So here if you see now this time we don't have any association within the parent entity, and we have a unidirectional association only in the child entity. That is just because of at the rate many to one fetch go fetch dot lazy, right? So in this case what happens, so total two tables, obviously customer table will be created just because of parent entity, and in the loan table, okay, it will create a new foreign key column with the name customer underscore ID. That is just because of this particular line. Okay, so these are the 6 possible cases, okay, in with respect to at the rate one to many, unidirectional, and as well as bidirectional association. Now there are a few more key points. Yeah, what and all we learned. Okay, so here it is highly recommended to keep cascade is equal cascade type dot all at the parent entity side only. Okay, and do not keep cascade attribute at the child entity side. So this is important. Okay, we should not keep cascading at both the side. Okay, so it is highly recommended to do to keep this cascading only at the parent entity side. Now, second point, do save and update and delete operations at the parent entity side. Okay, so, I mean, if at all we want to do all these operations, it is recommended to do it from the parent entity side. And whereas, I mean, we can do the fetch operation from both the sides. Okay. The- I mean, for that, there is no issue. I mean, we can do fetching operation either from parent side or the child entity side. There is no issue. Okay, so here if you see, in case if we wrongly link child with parent, so obviously then whichever is the owning side entity, obviously finally it will win. Win in the sense it will take high priority, and the what do you say, uh, its respective statement will get executed. Okay, if loan acts as a owning side in the sense what do you say, so that particular loan is linked to whatever of the customer, so obviously it will link to that specific customer. Okay, if customer acts as a owning side, customer dot get loans dot add of that particular loan, right? So by that way customer will win, and that customer will have that specific loan. Okay, so now if you see here, while fetching the parent records, here if you see while fetching the parent or child records, yeah. So we have encountered Hibernate fires n plus one problems, right? So just sometime before we have discussed this point also. Okay. And yeah, we can remove the child entity records of a specific customer ID with the help of orphan removal equal to true. This also I have already, what do you say, gone through this particular scenario. So yeah, that's it. I just explained all the possible cases of at the rate one to many bidirectional association. So if you like my video, yeah, please like and share and subscribe to my channel. Thank you.